I'm afraid I am going to deliver the last talk of the day in English, so I do apologize ahead. You all speak English a lot better than I speak Polish, so hopefully you'll be able to keep up. Any questions, please come find us. I think I'm now between you and beer, so I will try not to stand too much in your way. What I want to cover today is applying security policies to a container environment, whether this is OpenShift, Kubernetes, or some other, just normal Docker. I'm going to cover this with some of our open source tools. So Sysdig, we are a commercial vendor, but we produce heavily into the open source community. Our founder was one of the guys that co-created Wireshark. So he's a big fan of the open source community. We continue our commitment to the open source community. So although we've got commercial tools, half of what I'm going to cover today will be you can achieve just purely from our open source tooling. So an introduction to Falco, what Falco is. It is our behavioral activity monitor. So what we're doing with Falco is analyzing system calls. So we sit at the bridging between the kernel and the user space. And what we're doing is we're analyzing every single system call that your application's making for security kind of behavior anomalies, detecting what normal is, what abnormal is, and so on. We fully support your container orchestration platform. So if you're using, again, OpenShift, Kubernetes, you can apply this to different namespaces, different container images. So you've got lots of control of how these security detection controls are controlled and how you kind of own the configuration of that. At the end of last year, the CNCF adopted Falco as a sandbox project. So we, again, continuing our investment in the open source world. We fully released it to the CNCF. They're effectively in control of it these days. You guys can today go and fork Falco completely, start committing to it, start feeding back into it. Which I guess leads nicely into this. We always contribute to Google's Summer of Code. So any developers out there that want to help or just learn, you don't have to help feed back into it. You could just use it as part of your own learning, own personal development. We always invest in Google's Summer of Code, amongst other things as well. So a little bit around how we do the isolation and so on. The nice thing about a container is that containers fully isolate a process. A container should do one thing and should do that one thing well. So it means it's quite easy to understand and detect when a container is misbehaving. For example, should a database be forking processes? Should your RabbitMQ server be making outbound connections to the internet? So it means the ability to scope controls and kind of policy mechanisms to detect anomalies can become relatively easy for that. What we need to do is be able to profile how the processes within a container operate, and then use that to do our anomaly detection. So a little bit of history before we get into the details. Where we started with kind of this anomaly detection is we obviously started in the network. Looking at how do you understand your application is healthy or not? Well, we all start at the network. So we start with things like TCP dump. BPF was very closely followed by that. If you care to know, it's the Berkeley packet filter. And then we got into ethereal and snort, which was really the advent of our founder with his journey with things like Wireshark. And then Wireshark was your source of data to understand the health of your applications, what's going on in the network. You send traffic out to your users between client and server, and then something bad happens in the middle, and then you want to work out what happened. And that's where we started with network monitoring. Sysdig was founded or started as an open source project, back mid-2013, and Loris, our founder, was looking at a way to take that logic of Wireshark and Snort and apply that to the container space. How can you get that same level of visibility when traffic maybe doesn't even hit the network? And this is where the advent of Sysdig came from, was analyzing those system calls and deriving insights from that. Not long after that, that's where the birth of Falco came from. So analyzing these system calls, originally we built this as a performance monitoring tool, but actually very quickly we realized that this was really powerful from a security perspective as well. There's no lower level of security than analyzing those system calls. So this is kind of the history there. Snort is to Wireshark what Sysdig is to Falco, or Falco is to Sysdig, sorry. So what is it that we do? How do we build it? Introducing kind of the core components. First of all, we are sitting down at the host. And when I say host, this could be a virtual machine, it could be a cloud instance, it could be an OpenStack instance, or it could be a bare metal host. It's basically where is the kernel that's running my workloads. Again, could be a container workload, could be Cryo, Docker, any of those. Because the Sysdig agent, or the Falco agent, is sitting on the host, interacting and creating that bridge between the kernel space and the user space to give us that activity of system calls. We've now started to move this across to eBPF, which is Extended Berkeley Packet Filter. That gives us native access to all these system calls. So we don't have to ask you to install a kernel module that we've made, and lots of people don't like interacting with the kernel directly with third-party modules, understandably. So you can now take eBPF, which is just available, and we can use that as the data feed into our security and monitoring engines. The Sysdig agent, or the Falco agent if you're running open source, this is where kind of the magic happens. This is where we apply the anomaly detection. The rules engine sits within that, and then as we're kind of receiving the live syscall traffic, that's where we'll interpret that and work out, is this anomalous behavior or is this ordinary? Because of that, it means that the platform can be fully standalone. While the commercial tool does have a full back-end for management, if that ever goes offline, you still have your security engine in place on the host. So if you are under a major attack, maybe you're getting DDoS attacked. If your network isn't functional, your security layer is still operational, because all the configuration, the policies is pushed down and run locally. It also means it has a very, very rapid time to kind of action. So if you're taking an action as an output, say you've got an anomalous behavior, you want to kill that container, that all happens locally on the agent. So we detect the system call, we decide whether we should take an action, and we kill it. Normally, that is done within under a second. So introducing how to actually write these rules. This is where we get into some of the detail. There are kind of three concepts within writing the rule. You have lists, macros, and rules. These are fairly self-explanatory. A list is just a list. Now, a macro is where you put together a series of system calls to create kind of an output. So it's more of an advanced list. Think of it a little bit like a regular expression. The advantage of writing things into macros and lists is they're very reusable. You could have one list of trusted IP, a macro of trusted shells or trusted networks, and then you could reuse those over and over again across multiple rules, simplifying the management of those things. You write your trusted lists once, you write your known or unknown entities once, and then from there you keep reusing those. Talked over myself and ahead of myself. There's the description of those. So in addition to those, you have kind of filtering expressions. So this allows you to be much more than just Boolean operators. It's not just a match or an OR and an XOR. It's much more kind of comprehensive than that. So you can create quite complex filters around this to allow you to really drill down into what is anomalous behavior. Now, the tools behind building this are incredibly powerful, but also the nice thing there is that the community, being an open source tool, a lot of this information has already been written. So a lot of these rules, these policies are already available in the community. You can go and download these from our GitHub repos. You can look on our public Slack, and you can get help and assistance with these. But they are also incredibly powerful. We have several both open source users and commercial customers that actually dynamically write security rules. So you take the output of, just referencing the talk before, you take the output of, say, an OpenStack deployment where you have a dynamic IP allocated to nodes, to routers, to trunks, And you can feed that into the security engine to say, okay, now this dynamic IP is a trusted IP or an untrusted IP. We have people using that within, say, AWS, where you know you've always got a dynamic elastic IP, as should be. Onto here. So this kind of gets into the details of the granularity we can get to with the system calls. So we do the way we discuss system calls within Sysdig, and we use the same terminology within Falco, is slightly different to the native system calls because we want to make it a little bit more simplistic. So FD is, I broke it. FD is file descriptors. Processes are pretty self-explanatory, and events, or EVT, are probably one of the more powerful ones, because here we can look at, okay, what is a file open, what is a database forking a process, and so on and so forth. So we can get really granular in this level of detail. And then, of course, you use the kind of the classes of where does this apply. So, for example, I could say if an SSH connection is opened into a container, then trigger a policy. But if an SSH connection is opened into the host, that's okay. So you create a lot of the exceptions. No one should be SSHing into containers. Very, very bad practice, something you want to encourage people not to do. But SSHing into the hosts, it's still a bad habit that we all have. People still, making immutable infrastructure is really hard. Immutable containers, it's not so hard. Immutable infrastructure is very hard. So here you want to put in those different levels of policies and the different controls there to again, make sure you're not brushing everything with a deny policy, as much as that would be nice. So some very quick examples of kind of the simplicity of what we can do here. Once you understand the syntax and the way we're describing these different system calls and the activities, it does become quite familiar, as much as initially it's a fairly foreign language. So one of my favorite ones that we demo almost all the time is run a shell within a container. This could be someone SSHing into a container. It equally could be running a kubeexec IT into a container. You don't want to promote that sort of activity. And the other thing here is if that's a misbehaving admin, okay, slap on the wrists, teach them how to do it otherwise. But the other reason this might be an issue is if someone has found a way to do a remote exploit on your application. So the one thing that any malicious actor wants to do is to gain console access into your containers or into your host and applications. From there, they can attack sideways. They're within your perimeter then. They can do lateral movement. They can get under your radar. So this is a really good one for just identifying almost immediate kind of malicious activities in the platform. And a list of other ones that are fairly common, that we see fairly common in terms of the CVEs, the big vulnerabilities. If you look at, for example, the runc exploit that was discovered a few months ago, the overwrite the system binaries would have covered the runc exploit. The runc exploit was about buffer overflowing the runc binaries and then overwriting that runc with a malware package. So here you'd be able to detect that. If you analyze, if you do kind of threat analysis and look at what are the common goals of malicious actors, typically they come down to a fairly small set of rules, and that's what we're really looking to have coverage on with our out-of-the-box policies and out-of-the-box rules that you can find in the open source environment. So breaking down an individual Falco rule here. So you can see here we're looking at a container that runs Node.js. So here you can see is the event type an execv? So is this a process that's being executed? We're looking to see if the container image starts with the word node. And then we're looking to see if the process name is not equal to node. So a very, very simple process here is something pretending to be a node server that isn't actually a node server. So again, in terms of the idea of clean code, it's fairly readable syntax once you've seen it in kind of written in front of you. One thing we added, when did we add this? So earlier this year was the ability to audit Kubernetes events. Again, this was really important for establishing some of the privileged so you guys can definitely speak English better than I can. Privileged escalation vulnerabilities in things like Kubernetes, the control plane there. So a user that has authorized access was able to gain privileged access beyond what they have access to. By us being able to audit, by Falco being able to audit the Kubernetes events, we could capture that because we would see a request coming in, whether it's an authorized or otherwise. We could then evaluate those requests and take actions against this. So this, again, expands our coverage of not just the raw container, but also what's happening in your orchestration layer. The nice thing here is because things like OpenShift is variants on Kubernetes, you get the similar functionality out of OpenShift as well. And here's an example of what a Kubernetes audit event is that's generated. So this is, instead of analyzing the system call, now we're analyzing effectively a JSON object to see what type of activity that is. We can see here the different things the different parts of that JSON audit that we can then manipulate in order to create the policies here. So you can see what the protocol is that's coming in on when the timestamp is. Obviously, timestamping is very, very important when it comes to not just blocking these events, but also detecting these. So you can do future reports on these. And then again, in terms of giving you an example policy, here we're building several macros that help define what certain objects are within the Kubernetes audit events. So we have whether a container contains private credentials. Again, really powerful here. You don't want to be encouraging your developers, your DevOps teams to be baking clear text passwords and secret credentials into your Kubernetes events. So we define some examples of what the private credentials look like, wrap that up into a macro so we can reuse that. A very simple macro, which is define the config map. Again, just means we don't need to continually define that full syntax. It shrunk down our rule to just say config map. And then finally the rule there. So now we're defining this rule. So is someone creating, modifying, or patching an object to add to add private credentials to that? So now we've created a rule that normally would have gone kind of unnoticed. So we wouldn't have been able to detect that someone is injecting private credentials into my running containers within my OpenShift Kubernetes environment. But now we've got a basic rule that covers that. So I can start kind of encouraging those security best practices. The whole idea of shift left. Make security developers' problems as early as possible so that you're not retrofitting security later. And we all know that when you retrofit security, something breaks. So now a couple of kind of screenshots, just a little bit of a walkthrough to what we're doing within the commercial tool. So up until now, everything I've talked about is available within the open source tooling. So you can write those rules, you can write those detection engines. We've got some really good blogs on taking the open source tooling and running it through a response engine, which you can then fire that into something like Elasticsearch or Splunk. So you can do kind of future analytics on the different activity that's happening in your platform. We've wrapped a lot of that into our commercial tooling. So depending if you'd like to DIY it and build your own tooling, please go ahead, use our open source tools. If you're looking to someone to shout at and you want to pick up the phone and chat at me, that's fine. You can use our commercial tools. So what you can do here is you can take anything you've developed in the open source community within yourselves or something that someone else has developed and drop it straight in. Copy and paste it directly into the enterprise tool. So on the flip side, anything you write within the enterprise tool, you can drop and paste directly into the open source tools. So very, very kind of intercompatibility there. If you start with the commercial tools and then later decide to go open source, I'll be a bit upset, but you can do that because you'll have all that stuff natively for yourselves. There is a fair amount of power around how you scope the policies. So this is where we're natively talking to your orchestration platform. We're pulling in all the metadata tags that are already existing there. This will include your Kubernetes stuff. It will include anything in OpenShift, which also appears as Kubernetes objects. It will include things like your Docker tags and any other information you've got on there. You can use that as a way to then have fairly complex operators on how to differentiate these. A very simple one there is you can then say, okay, anything with the word prod in it, have an enforcing action. Anything with the word dev in it, I just want to have information only. Of course, you have centralized policy management. So in open source Falco, what you need is some way of managing the configurations across each of your hosts. You can obviously package that up into a config management tool. You can use Ansible, Puppet, Chef, whatever tooling you prefer to manage that as a deployment. Within the commercial tools, we give you that kind of baked into the tooling. So a central way to manage all your rules, apply the policies, apply where they're scoped to apply, as well as any actions out of the back of it, but also just a simple view of exactly what are my policies. And then the other thing that we provide that is a little bit more involved in the open source tooling, but we provide out of the box with the commercial tooling, is the ability to take different actions. So if I see anomalous behavior within my containers, I can do nothing. I can do a Docker kill or a stop, and I can do a Docker pause. The subtle difference there is if I do a Docker kill, that container is destroyed. Kubernetes comes along, it sees that my readiness check, my liveness check is failing. It cleans up that container and reprovisions a new one. So if you think of an example where I've got someone, a malicious player who's attacking my server, they keep breaching a policy, but you can kill that every time. Now, because Kubernetes is going to redeploy that, your service stays up. It's self-healing itself. Eventually, that person is going to give up. On the flip side to that, the Docker pause, this is going to pause that container. Kubernetes will again see that the readiness or liveness check has failed. It will try and remove that container, but because it's paused, it can't interact with it. So that service is going to get taken offline. Now, if you've got something where maybe you've got a container that you've downloaded from the internet and it is fundamentally broken, it's got some malware inside. It doesn't matter how many times Kubernetes redeploys that, it's always going to be broken. So actually, in those scenarios, you may want to shut down that service completely. That is service disrupting. So be careful with that. The last one, which is really powerful, probably one of the more powerful things, if anyone's played with Sysdig's open source tooling, you might have seen this before, but it's the ability to take a Sysdig capture. And again, one of the things we've baked into the commercial tooling is the ability to take this capture before the event happens. So in the Sysdig agent, we have an in-memory ring buffer that's constantly storing all of that syscall activity. At pointing of detecting events, we can dump that memory to disk. So it means we give you activity before the event happens, which is really powerful. I don't want to just see what happened, I want to see how it happened. Especially for security events, that's really important because I don't want it to happen twice. Bad things happen, it is a given, but I don't want those bad things to happen more than once. So, digging deeper into those things. This is, once you've taken a capture, you then have what we call an SCAP. So this is Loris's kind of progression from a PCAP in Wireshark. Now we have an SCAP, which is a system capture instead of or a syscall capture. Instead of a packet capture, we have the syscall capture. This is recording every single system call as well as the state of that machine for a short period of time. In this example here, you can see we're building up a kind of a view of correlation of activity. So we start at the very beginning with, I think it's about 100,000 system calls, but very quickly we overlay the different activities that we see across the different areas of system calls to build up this idea of correlation and then zoom in that time period to something that is a time period of less than a second potentially. What we can also do is pivot the information. So if you want to filter out all of the noise and I just want to focus on one container, very, very quick. Find that container, double click on it. I've now changed my scope. So anything I'm looking at is just relevant to that one container. So it's a very powerful tool for analyzing whatever it is and manipulating the data that's in there. Once you've drilled into the kind of the time period and activity you want to do, you can then start snooping on users. So this particular example is analyzing a shell within a container. So if I've got a shell within a container, I want to see what was running in that shell. So here we have a full record of every single command. If you were following the screen while I was talking, you'd have seen that there was a tarball. The tarball was extracted, and we can actually see every single file within that tarball that was extracted. Even if potentially this information doesn't exist anymore. This is a container. It could have died long ago. This person could have cleared up, as you can see, that if you maybe saw, they're clearing up their bash history. It doesn't matter because we've got this capture stored somewhere else in the database, so they can't interact with this information. But we've got a copy of it. Further than that, what we can do is actually drill into file contents. Because every I/O operation ultimately is a system call, what we see here is we drill into the information and we can see printable ASCII output of the contents of the file. In this particular scenario, we're looking at a malware being loaded, or a rootkit being loaded onto the host. This could equally be, I've got a container that's erroring. I want to look into the configuration files that this container is dependent on. Because we've got that file level of detail, you can drill into that. You don't need to go into lots of different sources of information. You focus on a single area and drill into that detail. And the other thing, because we've got this breadth of information, there's a lot of other information in here that can be very, very useful. So while we're not a log aggregator, we're not Elasticsearch, we're not Splunk, when we see these events, we do detect the different logs being written. So we will see log contents. So you'll be able to then analyze, okay, during this event, was there any HTTP errors generated? Was there any application errors generated? We can drill into specific Docker events or orchestration events as seen on here. So I'm going to finish at that point and let you guys have some alcohol, hopefully. Any questions at all, you can either come up to me now or we've got a booth just outside here. We've got some information on Falco on the stand, so you can go and have a look at the open source community, have a look at what we're doing in that network. A lot of information around our open source community on the slides here. Obviously, these are all being recorded. Hopefully, the slides will be made available as well. Any questions at all, please come see us afterwards. Been very nice talking to you guys. Hopefully, that was understandable, and thank you very much.